For lesson 7.1, beginning a brand new chapter, we're going to work a lot with radicals. This little table right here is going to really explain what could be happening. You're going to have odd roots. You might have third roots or fifth roots. And sometimes kids are even wondering, why are you calling them odd roots? Look at that little index in there, that little number in that crevice. When it's an odd number, that's considered to be an odd root, of course. You'll only have one value that would be worked out if you perform an odd root on a number. If you were to take an even root, like a square root, second root, or a fourth root, or a fifth root, if you're taking an even root of a positive value, like the fourth root of 16, you would get the positive and negative form. You'd have a plus or a minus. You always have two answers. If you're taking an even root of 0, you'd only get 1. If you ever take an even root of something negative, you'd get no solution, or no real root, I should say. Well, let's take a look at some of these problems. Thank goodness your calculator can be of tremendous help here, and we want to have our calculators out. It says find the indicated nth roots of a. Well, this is a third root, an odd root of negative 64. It's very tempting to think that there's no answer here. Very often kids will remember to chapter 5 and they'll say, wouldn't this be imaginary? Well, that's for even roots. Negatives are allowed inside of cube roots and fifth roots. A calculator will remind you. Press the math button. The math button is right here where I'm pointing. It's pretty close to that down arrow, all the way on that left-hand edge of the calculator. Go down to choice 4, and you'll get the cube root. You can just type in negative 64. You'd get negative 4. This means negative 4 multiplied to itself 3 times is negative 64. When you're looking at number 2, however, you're going to have an even root. And if someone said find the roots, the fourth roots of 81, there will be a plus minus associated with that. Now we'll worry about the plus minus in a moment. But to take a fourth root, or any higher root, like a fifth root, sixth root, and so on, what you have to do is type the index first. That 4 is right here in that little crevice. It's telling us it's a fourth root. First you press the 4, then press math, come down to number 5, and once you hit enter, the 4 is placed in the correct index position. If you took the fourth root of 81, you'd just get a 3, but again, that's plus or minus 3. When you look at number 3, of course, kids will correctly realize it's a square root. It's a second root. The square root never, when written out in conventional form, will have that index of a 2 in there. It's understood to be there. And we're going to take a plus or minus because it's an even root. But then real quickly we'll say, wait a minute, we're plugging a negative in there. Well, the square root button actually is a kitty corner to the 7 on a diagonal. When you hit second and then hit the squared button, you get that. If we type in negative 64, real quickly, you'd see that you get an error. And this means that there's no real root. You're not going to have even roots of negative numbers. So your calculator reminds you of all that information. Now, for number 4, this actually is applying what we just did, but in a solving context. To get rid of a third power, we're going to take a third root. So I'm going to take a third root on both sides. There won't be a plus or a minus because it's an odd root. But what we can do real quickly is just make the cube root appear, hit math. And I think we already know from our first example what we should be getting. It would just be a 4. And we're done. When we look at number 5, first get x alone. It's 1/2 x to the 4th equals 8. Multiply both sides by a 2. So you'd have x to the fourth equals 16. Now if you have x to the fourth equals 16, to get rid of a fourth power, you'll need to take a fourth root. However, you're going to have a plus minus. Whenever you take even roots, you're going to have a plus minus. That's the one thing that the calculator won't tell you. But remember how we get a fourth root. We press 4 first, then we hit math, come down here to number 5, and we can say, hey, what's the fourth root of 16? Well, you get 2. But don't forget, there is that plus minus issue. For number 6, it's so tempting. I can't tell you how many times kids will say, hey, add a 1 to both sides. But that minus 1 is trapped inside these parentheses being raised to the third. Really what you need to do is get rid of that third power first. Take a cube root, and I'm going to hit math. Bring this down over here. It's a cube root of 27. You can quickly see you get a 3. There's no plus or minus here. It's just a 3. Finally, add a 1. Just have this one answer of x equals 4. All right, well, we've got a little exercise here. 25 raised up to the 1/2. I mean, you could make the fraction bar appear if you wanted to, alpha y equals. But 25 to the 1/2, you'd see you'd get a 5. You try 16 to the 1/2, you should get a 4. Go 9 to the 1/2, you'll get a 3. Look, you can also do this with a 1/3. You could just go 1/3, 1 divided by 3. You're going to get a 2. 27 to the 1/3, you're going to get a 3. And 16 to the 1/4, maybe I'll type that out for you. 16, raise that up to the 1 divided by 4, you'll get a 2. Now, hopefully as you're looking at part A, you might be thinking you were taking a square root of the base. Square root of 25 is 5. Square root of 16 is 4. Square root of 9 is 3. For B, we're taking a third root, or a cube root. It's the third root of 8 would be a 2. The third root of 27 would get you a 3. This would be a fourth root, which leads us to this super important definition, that a to the 1 over n power is the nth root of a. It's the nth root of a. Super, super, super important. Similarly, if I gave you a to the m over n, you'll have the nth root of a, but now we're going to raise that up to the m power. Notice m is up high, it's in the numerator, it's up high here. N is down low in the denominator. N always goes in that little crevice where we write our index. Know these. We're going to have questions asking you to really convert from one form to the other. So let's move on to the back real quickly. When you're asked to simplify here, you know, I'll tell you the truth. For so many of these problems, what you can do is honestly just see if the calculator will help you. You can say, hey, 27, bump that up. You can say alpha y equals, to get a fraction if you'd like. You don't even need that fraction. I think we've seen that already. But you'd get a 9. You're more than welcome to do that. This, by the way, though, is the cube root of 27 and then squaring it. You could also break it down that way. But if I give you a negative power, hopefully you remember negative powers, you want to flip. You want to take that reciprocal. And you get 1 over 8 to the 2/3. So I'm going to just type in 8 to the 2/3 real quickly. And again, you don't even need the official fraction bar. That's a 4. So there's a 4 down below here. Please do that. When you see negative powers, first flip it, then just work out the positive power. Final answer is 1/4. Very similar problem right here for letter C. Negative exponent means flip. Go 1 over 16 to the 3/4. Let's maybe see what 16 to the 3/4 is. And you'll actually get an 8. So you have 1 over 8. These next problems can go quickly, but we have to remember what's happening here. The denominator of a fractional exponent always goes in that little index. So we'll have that third root of 5. The numerator is the 2. I always want to remind kids, and maybe this will be helpful. Look, the 2's up high, the 3's down low. Same thing here. 2's up high, 3's down low. Hey, look at this. 11 to the negative 1/3. Flip first. Just like we've been doing. Negative powers, guys, just take that reciprocal real quickly. And a third power, when you've got that 1/3 power, that's really the third root. You could put a 1 outside if you'd like, but it's not even necessary. For number 8, that negative exponent, let's flip that first. And then your denominator tells you your root. So we have a 5th root of 29. The 2 up here you can just write off to the side. Well, you can also go in the opposite direction. You can go from a radical to an exponential expression. You got the 4th root of 5 raised up to the 3rd. Hopefully you'll look at that and say that's 5 to the 3/4. The index always goes in the denominator. This is 1 over the cube root of 4. Well, that's 4 to the 1/3. But I'm going to bump that up and write that as 4 to the negative 1/3 power. Watch out for number 11, our very last one. This is down below 17 to the 1/4 power. I'm going to bring that up. So I'm going to have a negative. That's from the numerator, really. And then I'll have 17 to the negative 1/4 power. Okay, best of luck to you.